So we were doing human eye and the colorful world, correct? So in that we have studied till here the formation of rainbow, right? Next is twinkling of stars. I think this also we finished. Did we finish this twinkling of stars? I'm asking you people, am I on mute? No.
Yes, ma'am, it was finished.
Okay, the twinkling of stars is done. So next is early sunrise and late sunset. That means the sun appears to be raised above the horizon. So like this. So first let us understand the Tyndall effect. So what is Tyndall effect? What is Tyndall effect, children?
Scattering of light by collider particles.
Yeah, so Tyndall effect is nothing but scattering of light and it collides with the particles, correct? So that is what is called Tyndall effect. So I have told you, if there is a small hole in a dark room and there is a light beam which is coming, you can see there will be dust particles. There will be dust particles, and the light which falls on the dust particles, what will happen? It will scatter, correct? Hmm? Sorry. So it scatters. So that is what is called Tyndall effect. So here the Tyndall effect, for example, where can you see this?
Forest.
Forests, yes, in any dark room where there is dust. Even if you say the room is clean, how much ever you clean the room, there will be very, very tiny dust particles, correct? You cannot find a room which is ideally clean. What do you mean by ideally clean?
Without any dust particles.
Yeah, that is not at all possible according to me. Is it possible?
No,
Even if you,
anywhere there's light, you can see the dust particles.
yes, even if you clean it with a vacuum cleaner also, I don't think so you can have such a clean room or clean place, right? Yeah, so there we can see the Tyndall effect. Yeah, so now we got to know, yeah, even in cinema halls, the projector light, when it comes, you have seen that Tyndall effect, correct? Have you seen in theaters? It's been how long you have been to a theater?
I went recently.
Okay, did you observe this from the
Yeah, I
projector
know what
room?
you're talking about.
Yeah,
Yeah, if you look up and then you can see particles around that light.
yeah, when from that projector room you will be getting a beam of light which is falling on the screen, so that will be the picture, correct? So if you see
And
that
near
beam of
that
light,
beam of
you
light,
can actually follow the beam of light. Otherwise, we cannot see the light. Correct. We cannot see what is the path traveled by the light. Can you? The white light, is it possible to follow the path of white light? Not possible. Correct. In your room, can you see the path of light? No, right? But in a cinema hall, it's completely dark and only from a small hole the light is coming out. And due to dust particles, there is Tyndall effect, and that can be seen by us. Correct? That is how we can see the, or we can follow the path of the light. Understood? Got it, children?
Yes, ma'am.
Okay. Then next. So do you know how does this work actually in cinema theaters and all? From the projector, the light comes and all of a sudden it's just like a the projector what they use in your classrooms.
Yes,
Hmm?
ma'am.
Yeah, similar type of projector this is, but it's a little bigger one. That's it. Okay, it's similar type of projector. Here in this project, like in the projectors what they use in school, for that they will be just putting one pen drive and they can show you whatever is there in the pen drive. Correct? Or they will connect it to a laptop or a computer and then they will show whatever is there in the laptop or computer. Correct? Yeah. Here what they do is, to that projector light they will be moving in front of the projector light, the tape will be moving. So tape in which it's a negative actually on which the pictures are stored. Okay. So when that is moving in front of the light, it will get displayed. That's it. Understood? Now everything is being digitized. So it will be a digital, like a pen drive only. You just insert it inside and then you can just play. Fine. Understood this? Like a pen drive or like a CD. Understood this or not?
Yes, ma'am.
Okay. So now, yeah, I have one question for you people. Is it easy to catch hold of a mosquito? Why? Do you know the reason why? Why can't we
because they're
catch?
too fast.
That's not the reason actually. There is science behind it actually.
Yeah, wo.
Mm. Have you heard of this dog whistle? The dog trainers will
No.
have that dog whistle.
Oh, yeah.
I've heard of that. Yeah. Can we hear that whistle sound? If a dog trainer blows the whistle, suppose if a policeman blows a whistle, will you be able to listen to it? Will you hear it? Yes, we can hear it. In the same way, if a dog trainer will blow a whistle, will you be able to hear it? Have you ever seen?
No, I don't know.
You've not seen also. Not heard also? Okay.
No.
Okay, next class I'll show you. Actually, it will actually produce ultrasonic sound, which our human ears are human ears cannot you can say the human ears are not sensitive for ultrasonic sounds, so we are not able to listen to it. But dogs or cats, all these animals can hear ultrasonic sound. So that is the reason it is used only by a dog trainer to train a dog. So this whistle, so usually they use this whistle by in security reasons and all. Like suppose you are in some danger and you want the help of a dog. How do you call it? You cannot make noise. Then if you have that whistle and if you blow the whistle, the trained dog, it will listen to that. Only a dog can listen to it, correct? So that dog will get to know and it will come to your place. Humans will not be able to hear that. So in security reasons, like in military purpose or by the police, they all have trained dogs, right? So there they will use this. Okay, one day I will show you some video based on this. Okay. Now, next is, why is the color of the sky blue? So when white light enters our atmosphere, what happens? We have, suppose, let us consider this is our earth and we have layers of atmosphere like this, correct? Different layers of atmosphere is there. When the white light from sun, from here if you see, the sun looks very small to us, correct? So I'm writing a small sun. It means it is very far from us. So when the white light comes from the sun and it enters the solar system, what happens? There are many layers of atmosphere, I said, and each layer of atmosphere has different density, correct? The density of the layers of the atmosphere is different. It keeps varying. Some layers have higher density and some layers are lower density, or it is like rarer medium and denser medium, rarer medium, denser medium. It keeps changing. Okay. So what happens to the white light? So it will get scattered. Okay. So this white light, when it gets scattered, so whenever there is scattering, there is spectrum which is generated, correct? So what is a spectrum? Spectrum is splitting of the white light into its constituent colors. Which are the colors? Vibgyor. Got it? So the light which has very less wavelength will bend the most. Actually, we were supposed to see violet color or indigo. Instead, we are only seeing blue color of the sky. Reason is, our human eye is sensitive to blue rather than violet and indigo. That is the reason we can see blue color of the sky. Understood? I want some answer, yes or
Yes, ma'am.
no. Okay. Now, can you tell me why does river in river water or pond water looks colorful? Like it can be sometimes green or blue. Why is that? Do you have color for water? What is the color of water? So water is colorless, basically, correct? Colorless, and it has no shape also, right? It will take the shape of a container. Yeah. But if you see in a river or a pond or a swimming pool, suppose swimming pool, it looks blue in color. Why does it look blue in color in a swimming pool?
Ma'am, the tiles only they'll make blue color.
Yeah, so the tiles
Like,
are blue in color. That is the reason. Okay. What about river and pond? Sometimes it will look green and sometimes it will look blue.
ma'am, green maybe it's because of the algae.
Yeah, green is because of the marine plants. Not only algae, underground water plants you can consider. Okay, it is because of water plants. What about blue color? Sometimes it looks blue in color some places. Why?
Ma'am, because it is the reflection of sky. And
Yes, that
since it's
is the
blue,
reflection
we
of the
can see it.
sky. Yes, correct. Okay. If you see the same water during sunset or sunrise, it will look reddish in color. Correct? Because the sky looks reddish during sunset and sunrise. Hmm? Therefore, the water also will look reddish in color. Understood, right? Yes. This is the reason why sky looks blue color, because when white light scatters in the atmosphere, the light with lesser wavelength will scatter most. But our human eye is very much sensitive for blue color, therefore the sky appears to be blue. Then why does it appear red during sunset and sunrise?
And it has longer wavelength.
Yes, actually what happens during sunset and sunrise? Yeah. So during sunset and sunrise, actually, when you say the sun is set, then it means this is the, you know what is horizon now, correct? Horizon is your line of sight. Okay, understood? A straight line parallel to the eyesight of your eye. Okay, now when you are when you say the sun is set, it means the sun has gone below the horizon. So when the sun has gone below the horizon, but the sun rays are still reaching you. So when it is reaching you, it is going through different layers of atmosphere and then it is reaching you, correct? Here two phenomena will take place. One is due to continuous refraction, the sun only appears to be still here. Okay. But then the actual position of the sun is below the horizon. Understood? So from below the horizon, when the light is traveling, the light which can reach us is the only the light which has longer wavelength. Okay.
Yes, ma'am.
So that is the reason it looks blue color. So two things are happening. So there is scattering of light also. And why scattering takes place? Because in the atmosphere we have dust particles, water molecules and all these things. So therefore scattering takes place. And due to difference in the density of the layers of the atmosphere, there will be refraction which takes place. So due to refraction, the sun appears to be above the horizon, and due to scattering of light, it appears to be reddish in color. Understood? Any doubt?
No, no.
So same thing happens during the sunrise also. Next is, what do you mean by scattering of light? So scattering of light is nothing but the light getting split into different colors, and that is what is called Tyndall effect. Okay. Next, what all we have learned in this lesson? Okay, let's go to the exercise questions. Can anybody read this question?
The human eye can focus objects at different distances by adjusting the focal length of the eye lens. This is due to option A, presbyopia, B, accommodation, C, nearsightedness, D, farsightedness.
What is the answer?
B.
Yes, correct. It is because of accommodation. So what is accommodation? Power of accommodation. What is it?
The ability of the eye to focus both near and distant objects by increasing or decreasing the focal length.
Yes. Okay. Next question. Are you people making a note of this?
Parent text.
Okay, fine. Next. The human eye forms the image of an object at its
Retina.
retina. The image is formed on the retina. And then next, read, one of you, read the
The
question and tell
least
the answer.
distance of distinct vision for a young adult with normal vision is about 25 meter, 2.5 centimeter, 25 centimeter, 2.5 meter, 25 centimeter.
The answer is 25 centimeter. Sahana, can you read the next one?
The change in the focal length of an eye lens is caused by the action of the A, pupil, B, retina, C, ciliary muscles, and D, iris. I think it's C.
Yes, correct. It is C, ciliary muscles. Okay. Next, a person needs a lens of power minus 5.5 diopter for correcting his distant vision. For correcting his near vision, he needs a power of he needs a lens of power plus 1.5 diopter. What is the focal length of the lens required for correcting distant vision and for near vision? So there are two things given. So first, power of lens is given. So let two powers are given. So let us take one power as P1, that is minus 5.5 diopter. And they have given one more power, that is P2 plus 1.5 diopter. Correct? Minus 5.5 diopter, he needs it for correcting distant vision. So what will be the focal length? Now what is the relation between power and focal length?
Power is 1 by focal length.
Yes, they are reciprocal, you can say. So P is equal to 1 by F. So we can say now they have given P is minus 5.5, correct? Which is equal to 1 by F. Then what is the value of F? F will be minus 1 by 5.5. How much is that? So if you shift the point, it becomes 55 and here it becomes 10. So it will be
2 by
minus
11.
10 by 55. How much is 2 by 11?
Okay.
Sorry, didn't get you. 2 by 11.
Yeah, no.
We get decimal 0.
Sorry.
0.18.
Okay.
181818.
Okay. So F1, we will call this F1 because for power 1 it is F1. So it will be minus 0.18. What will be the unit for focal length here?
Meter.
Yes, it is meter.
Meter. Yeah.
Diopter is the power. Diopter is the unit of power only for focal length in meter. Okay. Next, can you find out what is the value of f2 in the same way?
Two by 3.
2 by 3. So 2 by 3 is?
0.667.
Yes. So it is actually 0.666 recurring. So we can stop it like this, or 0.667 meter plus 0.667 meter here. Correct? Understood, right? Nice. Next. The far point of a myopic person is 80 centimeter in front of the eyes. What is the nature and power of the lens required to correct the problem? Can anybody tell?
U will be infinity.
What is
V
given? You
will
have to tell me first.
and I have given that image distance.
Sorry.
And I have given image distance.
Ma'am, 1 by f will be 1 by 80. Okay, then f will be minus 80
It is not 1 by
centimeter.
80. It is. So now they are telling the image distance is given and it's a far point. So it is minus 80. We have to take 80 centimeter. So 80 centimeter is nothing but 0.8 meter.
Yeah. And then we put 100 down.
100 what?
Below 80.
I didn't understand what you said.
Ma'am, 1 by f is, what was 1 by f? It was 1 by minus 1 by 80, right? And then f will be?
This will be minus 1 by 0.8. Because you have to take in meters only.
80 centimeter. Oh, okay. Why can't we take it 80 centimeter and then divide by 100 again?
It's the same thing.
But my brain is working like that right now.
Or you can write like this. 1 by 80 into 10 raised to minus 2.
Ma'am, you can just put 100 by 80.
That also can write, yes, minus 100 by 80. So zeros you cancel. 2 4s are 2 5s are. So you get minus 5 by 4. So 5 by 4 means 1.25. So minus 1.25 diopter. Understood this?
In class we did the complex method.
Why so much complex method?
And they took object distance as infinite and image distance as minus 80 centimeter. Then we calculate 1 by f is equal to 1 by 8 minus
Oh
1
my
by
god, not required. Yeah, that's what I said. One problem can be solved in different methods. It's not necessary that every time you have to go roundabout. See, they have given to calculate the power of lens, the focal length is required. So from the given condition, it can be understood that focal length, see when they are telling near point means it is nothing but the focal length of the eyes, correct? Near point or far point? Sorry, far point. Far point is nothing but the focal length of the eyes. So focal length is given in a different way to you. That's it. See, it's not a mistake by anyone. Your teacher also has not done anything wrong. It's like sometimes what will happen, we will be thinking something. As soon as we see the question, what we will get, that we will take first. So first what you have to do is think calmly. That's the reason I say read the question 2 times. Okay, if you understand the question and write what is the given data, half of the question is solved. The other half is just substitute in the formula and calculate. Okay. Yeah. Now, a quick relogin. What's the time? Oh,